Hi, I'd like to talk a little bit about your first lab in Physics 152. In this lab, you are going to be looking at the period of a spring as it oscillates up and down and how it relates to the spring constant. So remember, a spring constant is purely a function of the material of this, how stiff the spring is. The symbol for spring constant is K, and we learned about spring constant in Physics 151 when we talked about Hooke's law, which said that the restoring force, or the force that causes a spring to bob up and down, is equal to the spring constant times the stretch of the spring. So if you stretched it a certain amount, if you multiply that by the spring constant, how stiff it is, which is measured in newtons per meter, then that would tell you what the restoring force was of the spring, how much force it was using to oscillate up and down. What you're going to do is you're going to look at various, come back here. There we go. So you're going to look at various springs and you're going to measure the period of them. So in this lab, you will be choosing the springs, that's your independent variable, and for each spring, you're going to be measuring the period of oscillation. And the period of oscillation is the time for just one complete bob up, down, and back to where it started. So let's give you some pointers. You're going to choose a mass and you're going to choose an amplitude so that you always pull it down to the same place and you always have the same mass on it at all times. And then you're going to pick a spring to use and you're going to press load. So this is spring D, 50 grams, amplitude 2. And when I press play, she sets it into motion. So you can see it's going to be really hard. Excuse me. It's going to be really hard to measure just one oscillation. So how do we do that? Well, we're going to turn on our tools and we're going to get the stopwatch, okay? And we're going to place it somewhere where we can see it. And I'm going to reload this. And I'm going to play this. Okay. If I stop it, it'll give me the timestamp, right? You're used to this. So what I want to do is I want to get a point where it's at its lowest point. I want to write down that time. Okay. 2.5833. And I want to count maybe 10 complete oscillations and stop it after that. So what is a complete oscillation? Well, a complete oscillation, you start down at the very bottom. Okay, start down at the very bottom. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to try to get it right there at the lowest. And that ended at 6.133 seconds. So that's the time for 10 complete oscillations. If I divide the difference between those two times, it started at 2.5 something or another, and it ended at 6.1 something or another. If I subtract those, that's going to give me the total time for 10 oscillations. And I divide that by 10, that's my period, right? Because that would be the time for one. So the more oscillations that you can do, probably the better average period you'll get. So spring D is going to have a certain period. So you are picking the spring and you're measuring the resulting period that it has. The variable that you pick and control is called the independent variable, and that's the spring constant, right? Because you're changing springs. with different stiffnesses. And the variable that you actually measure in response to that, you're seeing how the period changes with a different spring. You're making that measurement. That is called the dependent variable. And when you make a graph, you always graph dependent variable versus independent variable, or y versus x, right? So our independent variable is our spring constant, and that'll be graphed on the x-axis. Our dependent variable is what we're measuring. It is going to be graphed on the y-axis, and that's our spring constant. So later on in the lab, they're going to give you a list of what the spring constants are. So the spring constant for D is 22.87, and you will have a period that correlates to that spring constant. So that's going to be 1 point on your graph. Then you're going to pick at least a total of 7 different springs. And for each spring, you're going to have a spring constant, which is the y variable, and you're going to have measured and calculated the period, which is the x variable. So that's going to be a point. So you'll have 7 of those because you can do it for 7 different springs. And you'll make a graph of it. And you're going to look to see if that's a linear relationship or a parabolic relationship or what it is. So you want to see what the relationship is between period and spring constant. Is it linear? Is it a parabola? Is it an inverse relationship? And you'll do the appropriate curve fit on it to figure that out. And to verify, let's say that you think it is a parabolic fit. You're going to, if you get a best fit and you did a parabola, an x squared graph on it, and it seems to be a good fit, then to see if it is, you would plot the spring constant squared versus the period, and it would be a straight line. So you're going to do some linearization to verify your results. And if you have questions about that, please let me know.